I'd like to start class today by having you do this warm-up. Press pause on your video and then press play again when you're ready to see the answers. You'll notice the first answer is achieved by distributing the 3p squared to the 6p and then also to the 2. Over for number 2, it's a little bit different. What I have to do is distribute the 6a to both of these terms and then distribute the 2 to 7a and 7 and then combine like terms. So you would have 6a times 7a, which is 42a squared, then 6a times 7, which would be 42a, plus 2 times 7a, which is 14a, and then 2 times 7, which is 14. When you combine these like terms here, you get 56a, and that's where the answer comes from. You might also recall this. That stands for first, outer, inner, last. So if you look, here are my first terms, they get multiplied. That's when I distribute the 6a to the 7a. The outers is when I multiply the 6a, 6a and the 7. The inner is when I multiply the 2 times the 7a, and the last is when I multiply the 2 by the 7. It's just a nice way to remember, but quite honestly, this is not something I think about. I usually think about it in terms of distributing because it will work when we have more than 2 terms in each of the factors. Now, the next thing I want to talk about is how to write a number in scientific notation. Whenever you do that, you have to have a non-zero number in the ones place. So in this case, I would start with the 4, and then I would have the 0.35 after it. So nothing in the tens place, nothing in the hundreds place. I have to have a non-zero number in the ones place. Now, this gets multiplied by 10. The number of digits I would have to move my decimal over from this 4 this way is that's the power of 10 I'm going to multiply it by. So I go back 1, 2, 3, 4, 5, 6. So I'd have to multiply that by 10 to the 6 to get 4,350,000. Now, with this number, again, I want a non-zero number in the ones spot, so that's my 5.67. So I have moved my decimal place 1, 2, 3 spots backwards. So this is times 10 to the negative 3. Now let me say that again. To get my decimal place here, I have moved my decimal place 1, 2, 3, 4, 5, 6 digits over. Did I say that right? I moved my decimal place 6 digits to the left to get here. It's 10 to the 6th. To get my decimal place after the 5, I've moved my decimal place 5 digits to the right. So if I move to the right, it's a negative exponent. If I move to the left, it's a positive exponent. So 4.35 times 10 to the 6th, and this one's 5.67 times 10 to the negative 3rd. Now, the next thing I want to do is simplify this. You'll notice that both of these are written in scientific notation, but what's kind of nice about it is it's a product, so I can simplify it just as I simplify any kind of expression with exponents in it. So I'm going to take the 4.4 and divide by the 2, and that gives me 2.2. Then I have 10 to the 3rd over 10 to the negative 1. My exponent is bigger in my numerator than it is in my denominator, so the 10 is going to stay in my numerator, and it's 3 minus negative 1, which is negative 4. And that is the answer. Now, I'd like to talk today about polynomials primarily. A polynomial is an x in x is an algebraic expression of the form, and I have, this looks kind of intimidating, but really what it is I have a number times x to some power, and then another number times x to a power 1 less than that, and so on until I get to where I just have another number there without an exponent at all. So when I look at all of these a's, they're just different real numbers in front of the x's. So it's a polynomial here where these a's are real numbers, where a to the n, not a to the n, a sub n is not equal to 0, and n is a non-negative integer. Now, when I'm talking about the degree of a polynomial, oops, I moved this over somehow. Let's get that back. When I'm talking about the degree of a polynomial, I'm talking about the highest exponent. I think I have this on the next page. No, I don't. So the degree is the highest exponent. In this case, it's n. Okay, it's the highest exponent. The leading coefficient is the number in front of the variable with the highest exponent. So in this case, it'd be a sub n. It's the number in front of the variable with the highest exponent. That is what a sub n is. Now, the constant is the number without a variable after it. So if I go back and I look, in this case, my constant is a sub 0. So this is the number with no variable. So let's look at some examples. These are both polynomials. Poly means many, and nomials is nomials. Each nomial is a term. So if I look at this, I see 3 different terms. That is a polynomial. Now, my degree is the highest exponent. So in this case, my degree is 6. Now this is organized very nicely from highest exponent to lowest exponent. That is standard form for a polynomial. Sometimes my terms are all mixed up. If I come and I look over here, my degree is still the highest exponent, but you'll notice it's not in the front. So my degree here is 4. If I were to put this in standard polynomial form, this would be x to the 4th minus 3x to the 3rd plus 2. The next thing I'd like to talk about is the leading coefficients. The leading coefficient is the number in front of the variable with the highest exponent. So in this case, it's 5. Over here, let's copy that. Over here, it is the number in front of the variable with the highest exponent. See that hidden 1 there? The leading coefficient is a 1. It doesn't matter that it's not beginning with the 1x to the 4th. What matters is that if it was written in standard form, you would see this 1 out here in the front of my expression. Now, the next thing I want to find is the constant. The constant is the number with no variable after it. So you'll notice that's a 1. My constant here is 1. Next, my constant is 2. Right from there. Adding and subtracting polynomials. You may only add and subtract like terms. Like terms have the same variables with the same exponents, no matter what. What's going on here? Same variables with the same exponents. So let's look at an example. So notice I have a polynomial here, I'm adding a polynomial there. You are going to add the terms that are like terms. So just to get you started, the negative 6x to the fourth is a like term with 7x to the fourth. We have the same variables and the same exponents. Now, number 1 we're adding, and number 2 we're subtracting. Make sure you remember to distribute the negative. Okay, give it a shot. Press pause on your video when you're ready to see the answer. Press play. And here are the answers. If you made an error, go press pause and check your work and perhaps talk to your neighbor and see if you can't figure out where that happened. Multiplying polynomials. Remember I talked about the word FOIL and how it doesn't always work. It doesn't work with when one of my factors has more than 2 terms. So I like to think of it as distributing. We're first going to distribute the n, then we're going to distribute the 8. And I like to organize myself as I go so that I can add my like terms. You'll see what I mean in a second. I'm going to distribute the n to the 4n squared. That's 4n to the third. Now the n goes to the negative 6n. That's minus 6n squared. N to the 3 plus 3n. Now we're going to distribute the 8. 8 times 4 is 32n squared. Now I am going to put that right under my like terms so that when I'm done, I'll be able to add straight down and not get myself mixed up. 8 times 6 is 48. That's minus 48n. And then I'll distribute the 8 to the 3. That's 24. Now it's lined up really nice for me, and all I have to do is add straight down. So I'd have 4n to the third. 32 minus 6 would be plus, plus 26, right? Yep, 26n squared. And then minus 48 plus 3n would be minus 45n. And then I'd have the 24 on the end. So there you have it. Adding or multiplying polynomials. You distribute the terms. Distribute and then distribute the second term. And if there were 3 terms, you'd distribute each of those over the second. Now, I want to try another one. Remember, we want to organize our terms. So first I'm going to distribute the 8n squared to the rest. So I have 8n squared times 6n squared. That is 48n squared. Then I have 8n squared times 6n. That is another, oh, I said squared, not squared. My bad. It should be 48n to the fourth. 8n squared times 6n squared is 48n to the fourth. Now we'll distribute the 8n squared to the 6n. That would be 48n to the third. Then the next thing I'm going to do is distribute the 8n squared to the 3. That's plus 24n squared. Now, next, we're going to distribute 8n to each of these terms, but I'm going to line up my like terms just like I had in the previous example. So 8n times 6n squared is going to be 48n cubed. We'll distribute the 8n to the 6n, and then we have again 48n squared. Then distribute the 8n to the 3. That's plus 24n. Now we'll distribute the negative 5. Negative 5 times 6n squared is minus 30n squared. Negative 5 times 6n is minus 30n. And then negative 5 times 3 is minus 15. Are you tired yet? I am. But we keep going. So all we have to do is add straight down our like terms. So the first number, or first term, would be 48n to the fourth. I'll add these together. Let's see, that's 1696n cubed. Then I have 24 plus 48n squared. So I'm going to just help myself with my calculator. 24 plus 48 minus 30 is 42. So this will be 42n squared. Then I have minus 30 plus 24n. So that would be minus 6n and then minus 15. And there's your answer. It does make things easier if you organize it like this. Otherwise, you're hunting down which terms are like at the end, and you're likely to make an error. So if you organize yourself, things will go well. Now, I want you to multiply these numbers. When you are done, press pause on your video. When you're done, press play again to check your answers. Now, I did this very intentionally. Did you notice something happened? I have no middle term in each of these. It's kind of nice. It was 2p plus 2, 2p minus 2. Over here it was 4 plus 5n, 4 plus 5b times 4 minus 5b. These terms, these factors, are called conjugate pairs. And that is going to end up helping us later. Now, I want you to multiply this, or maybe we will do that together. We have x plus y squared. I talked yesterday about the fact that you cannot distribute this exponent inside when you have a plus symbol there. This is x plus y times x plus y. So it ends up being x squared plus 2xy plus y squared. Take a minute, press pause on your video, and multiply this out. When you're ready to see the answer again, press play. Okay, the answer to this is x to the third plus 3x squared y plus 3xy squared plus y cubed. And there is a pattern to this, and we're going to see that very soon. It's helpful when you're multiplying binomials. But let's do a few more first. Multiply this. When you're ready to see the answer, press play. So this would be x to the fourth. Ooh, I need my pen back. What's going on here? Let's try that again. X to the fourth plus 4x to the third y plus 6x squared y squared plus 4x y cubed plus y to the fourth. Pretty nice that I know the answer right away. Now, what's happening here is a pattern from Pascal's triangle. I don't know if you've ever seen this, but let me show you what the triangle looks like. It starts with a 1. It has 1s on both diagonals. And the next row is always the sum of the 2 that are right above it. So 1 plus 1 here is 2. And then I have a 1 on this end. I start again with a 1. 1 plus 2 is 3. 2 plus 1 is 3. Then I have a 1 over here. Then it goes again. 1, 4, 6, 4, 1. So you'll notice x plus y to the 0 is 1. That corresponds, let's see if I can draw this the way I want it to be, with that. X plus y to the first power corresponds with this. X plus y squared corresponds with this row. X plus y to the third corresponds with this row. And if you recall, this one corresponds with this row. Now, you'll notice that these are the coefficients when I multiply all of this out. You have to notice the pattern. If we go one more, I'd have 1, 5, 10, 10, 5, 1. So if I wanted to do x plus y to the 5th, it would be x to the 5th. I start with whatever is here to the 5th power, that's the exponent I'm raising this to, plus 5, that's my next coefficient, times x, my exponent on my x, it decreases by 1, and the exponent on the y increases by 1. The next coefficient is 10, so that's plus 10. X, the exponent's going to decrease by 1, so that's to the 3rd. The exponent on the y is going to increase by 1. Then I'm going to add another 10. That's my next coefficient here. I think I'm going to move this out of the way a bit. Let's see if I can do that. Okay, and my exponent on the x is going to decrease by 1, and the exponent on the y is going to increase by 1. The next number is 5. Exponent on the x decreases by 1. On the y, it increases by 1. And then finally, I'm left with the 1 as my coefficient. The exponent on the y increases by 1. Exponent on the x decreases by 1. Isn't that better than multiplying it all out by hand? Oh, I just did that. Haha. Now, this is a little bit different because now it's something other than just plain terms here. So we still have to do Pascal's triangle. But now this, let's write this out for a plus b. So if I imagine that this is a plus b to the 3rd power, where a is 1 and b is 2x, I would expand this using Pascal's triangle. So I'd have a to the 3rd plus 3a squared b plus 3ab squared plus b cubed. Now I'm just going to substitute in 1 for a and 2x for b. So this becomes 1 to the 3rd power, which is just 1, plus 3 times 1 squared, which is just 1, times 2x plus 3 times a, which is 1, times b squared plus b cubed. So now we'll simplify. 1 plus 6x plus 3 times 2 squared, which would be 12. So it's 12x squared, plus 2 cubed, which is 8, 8x cubed. And there you have it. And it's better than multiplying out the 1 plus 2x times the quantity 1 plus 2x, and then taking the result and multiplying by 1 plus 2x again. Much, much, much quicker. Okay, now that we're done with our video, we've talked about polynomials, we've talked about adding and subtracting them and multiplying them. I want you to have some time to practice. So take a look at Schoology and do your homework. I will see you on Monday.